All right, I'm going to go ahead and get started. So hello again, everybody. Good morning. Welcome to this week's Webinar Wednesday. This week, we're going to be talking about Creo Simulates. This is going to be a multi-part webinar series. In this part one, we're going to cover an introduction to simulation in general, and we're going to look at running a basic structural static analysis in Creo Simulate. So just going to take a quick look at our agenda for today. I'm going to start with a brief introduction to myself and PDSVISION. I'll then get into an overview of simulation. I'm going to talk about why we run simulations, what the benefit there is. I'm going to talk about the different simulation extensions that we have access to in Creo. There are a lot of PTC products that kind of fall under this simulation umbrella. So I'm going to talk about what options we have there. I'm then going to go into a case study. One of our customers that uses simulation, uses a lot of different parts of the software, uses it in a really advanced way. Then I will talk a little bit about Creo Simulate itself, talk about the licensing and the setup of that, talk about how you can get access to this. I think a lot of you are actually already going to have access to this. But I'll cover all that as well. I'm then going to get into a linear static structural analysis example. This is going to be run in Creo Simulate. This is a pretty basic example because I think it's where you have to start when you look at simulation. We're going to be doing an analysis of a bracket part. This part is going to be loaded, and we are going to look at how this part is going to experience that load, stresses that that are going to result from that, the deformation that's going to result from that, etc. And then at the end, I will open it up to questions. If you all have questions in the meantime, there's a question and answer area of GoToWebinar. So you can feel free to submit questions. I'll try and look at this as I go. So if you ask a question, I'll try and cover that while it's still fresh on everybody's minds. But if I don't get to your question, I'll definitely get to it at the end. All right. So a little introduction to myself. I've been working at PDSVISION for 5 years. My name's Sebi. I've been working at PDSVISION for 5 years. I've been working with CAD and simulation for about 10 years now. I've used Creo, I've used SolidWorks, and I've used AutoCAD. And I come from a mechanical engineering background before I got into Creo. My company, PDSVISION, we are the largest partner worldwide of PTC and a rapidly growing partner for ANSYS worldwide. We have a really excellent global team, and I like to think of us as a complete PTC partner because we don't just sell software. We offer services such as cloud hosting, training, help desk, consulting services. For our users today, we offer simulation services, Windchill remote admin, and I'm sure a whole bunch of things that I'm blanking on right now. PTC products that we support. We also work with some other companies to support some other pieces of software that we think fulfill some other niche that the PTC suite does not offer. Big example to highlight here, especially for this simulation webinar, would be ANSYS. ANSYS is one of, if not the leader in simulation, and there's a lot of integration of ANSYS into PTC products as well. So besides ANSYS having their own suite of products, we do have access to some of that directly inside of Creo. So we're a global partner for both of these, and additionally the other things on the screen, for example, KeyShot, Moldex 3D as well, just accomplish something that the PTC suite we feel does not. Okay, so I'm going to jump into an overview of simulation in general. You may be wondering why run simulations. The bullet points we see on the screen here, so lower life cycle cost, reduce time to market, designed to realize price premium, increase quality and performance, reduce product development costs. All of these are basically saying that this is going to help you design your products better and in less time. Using simulation, you're able to understand how your product is going to react in the real world when it's put under the stresses and strains of everyday use. But beyond that, you can understand why it behaves that way. So for example, if you design a product in Creo, you design a bracket, and then you go ahead and you go to test out that bracket, and you find it fails along a certain edge. Creo Simulate, first of all, could have caught that issue in the design process. You're able to expose it to the loads that it's going to be seeing in the real world, and you'd be able to recognize if this part is going to fail. But beyond that, we can understand why this part is failing and how we can improve it. By using the tools in Creo Simulate, we can see the areas of the part that are exposed to the highest stresses. We can then make design changes, either on our own or with the help of the software itself. It can help us make those changes in an optimal way. That way, before we get to that testing and failure stage, we can identify those failures and we can optimize our design so that the failures are not going to happen. We can manufacture our parts at the lowest cost and highest safety possible. So that is the idea here. I think that pretty much any fields that you have can benefit from simulation. The idea is to avoid failures, make your design better, also reduce the amount of time it takes, reduce your testing time, your time to market, all of that good stuff. Now, Creo has a whole lot of simulation extensions available. So on the left side of the screen here, I tried to group these into a top section that has what I consider the main simulation tools, those top 4. Those include Creo Simulate, Creo ANSYS Simulation, Creo Simulation Live or CSL, and Creo Flow Analysis, which is a CFD tool for computational fluid dynamics. Those 4 I would describe as full simulation tools. The top 3 are mostly going to be focused on structural analysis, with some exceptions. We have thermal analysis in all 3 of the top ones as well. In Creo Simulate, we have modal and buckling, fatigue analysis, a whole lot of other options available to us. And Creo Simulation Live also has some flow analysis capabilities built into it as well. So there's some overlap between these 4, but they're all, for the most part, fully functioning simulation tools that specialize in a specific area, like structural, fluid flow, thermal, etc. In this webinar, or at least once I get to the demonstration, I'm going to be talking about Creo Simulate. We are going to cover the rest of this stuff going forward in future webinars. We've already covered many of these topics, but just as far as going forward, we are going to hit this stuff. This webinar is just going to focus on that top one, Creo Simulate. Additionally, so in the bottom section here, we have a whole lot of things that are related to simulation as well. A lot of very, very exciting new extensions that have been built into Creo in the last several years. We have generative design, and that's what we see over on the image on the right side of the screen. Generative design allows us to load up our model with how it would be loaded in the real world. And then Creo is actually going to generate that geometry. We can see that those supports are are really, they kind of look like they're generated by an AI. They're really complex. What's happening there is Creo is optimizing our design. It's keeping the material requirements low enough, or as low as possible rather, while making the model strong enough to not fail under the loads we give it. So generative design uses simulation to generate 3D material. I think it's extremely cool. We have Creo additive manufacturing for use with 3D printing, human factors analysis, mechanism dynamics for any assembly that has movement involved, mold analysis, and many more. So as sort of a case study on how you can use simulation, how you can use multiple different tools that PTC offers to really improve your products. I just want to mention the company American Standard, or LIXIL. They are one of our customers that did a presentation this year at LiveWorks. This is a really awesome presentation. At least I think so, for someone who's really involved in the simulation side of Creo. I would definitely recommend checking it out if you want just an idea of how a company can use these tools to really improve their products. I put a link to the video on the screen on the left there. I would encourage you to check it out. This would be a good time to mention this video, or this webinar rather, is going to be uploaded to YouTube. It'll probably be uploaded to YouTube within a couple days. You can find it on our YouTube channel, PDSVISION. So if you want to come back and find this video link, you can definitely do that on YouTube. And I got a question relating to that, but yes, the webinar is recorded. It will be on YouTube in just a day or two, usually. So LIXIL, or American Standard, they specifically use Creo Simulation Live, Creo ANSYS Simulation, and ANSYS itself. They use each of these tools for something different. All three of them combined, they're able to get a really awesome product, really awesome results. So that's the goal here. At least the long-term goal is to get to the point where ideally you're able to use these tools, whichever ones benefit you, in an ideal way. Now in this webinar, as I mentioned, I'm going to be talking about Creo Simulate, or Creo Simulation. I find this is a really good place to start when talking about simulation, because as of maybe, I think 2020, might have been 2019, might have been 2021, but just in the last couple of years or few years, PTC has made Creo Simulation available to the vast majority of Creo users. So as I said, 2020-ish, the base level subscription of Creo, so Design Essentials, the tier 1 license, as of 2020, that includes the base level of Creo Simulation. So there are a whole lot of people who have access to Creo Simulate that either don't realize they have access to it, or they're not yet using that functionality. So for that reason, I think Creo Simulate is a great place to start. It's going to be free for a lot of people. This is a simulation tool that has been around for over 20 years. I think it's close to 30, but under a different name. It was released as Pro Mechanica. It's gone through evolutions. It's now Creo Simulate. This is a reliable and tested, tried and true simulation tool. The results are going to be very accurate for the most part. It uses a P method simulation technology. Not going to go into detail on that in this webinar, but it does have implications like reduced meshing time. And it has a wide range of features and capabilities. In fact, I would say the widest range of any of the Creo simulation tools. So nonlinear materials, for example, if you work with those and you want to run simulations, you're going to be likely doing it in Creo Simulate here. And lastly, the point I mentioned at the start, the base level of the software, Creo Simulation Elite, is available for free with a subscription to Creo. So as long as you're on Design Essentials, the tier 1 subscription license, you have access to this. Now, the exception to that is if you are on a locked license for a previous version of Creo. So instead of paying a yearly subscription to PTC, if you still have, for example, Creo 3 licenses that are perpetually stuck on Creo 3, that is the case for some people that aren't on subscription. In that case, you may not have access to this. If you are curious, if you're not sure if you do have access to this or not, and you'd like to find out, we are happy to help with that. I can just take a look at your account on ptc.com, take a look at your license, figure out if you have access to this. As I said, if you're on subscription with PTC for Creo, you should have this. So what can Creo Simulate do? What are the different license tiers? So the license tier on the left, Creo Simulation Elite, that is going to let you do linear static structural analysis, which is the example I'm going to be doing today. We can see that the different license tiers give you access to different features. With the first license tier, so Creo Simulation Extension, we get modal buckling analysis, steady state thermal, design optimization, contact analysis, and mid-surface shell compression. Big ones with advanced simulation are going to be nonlinear contact, nonlinear materials. Those are both very relevant anytime you're using nonlinear materials, of course, but that's going to be a lot of people. It also gives access to large deformation, transient analysis, dynamic analysis, modal analysis, etc. You may notice the note at the bottom, Creo Parametric includes simulation light. I would just ignore that. It's pretty useless, to be honest. If you don't have access to Elite, I wouldn't recommend using light. Thankfully, almost everybody, as I said, has access to Elite at this point. So we're getting to the point where we can basically forget simulation light exists, and that makes me happy because I don't think it's very good. Simulation Elite, though, so that first license tier that most of you should have, really, really great. I'm really glad that that's available, that people are going to be able to get in here and start working with structural analysis. So before I jump into my demo, to just kind of wrap this up, regardless of where you are on your simulation journey, so how much you are currently using the software, we are able to help with that process and hopefully make sure you're getting the best use out of the software. If you're not using simulation at all, you probably have access to it. We're happy to help you get up and running. If you are using some level of simulation, there's probably additional tools that you're not yet aware of that we're happy to walk you through, and we will be doing in this series going forward. Okay, so in Creo Simulate, you're generally going to follow the process we see on the screen when you're doing simulations. So step 1 is the model definition, and that's going to be done in Creo Parametric. That's going to include creating the part, obviously, doing the modeling. This step is also going to include simplifying the model. If you have a very large model and most of that model is not relevant for your simulation, you are definitely going to want to simplify that model down. You want to make your model as simple as you possibly can. The reason for that is that simulations are going to take longer. If your model size is bigger, it's going to make your mesh size bigger. So as much as you can in Creo Parametric, we are going to want to simplify and remove the irrelevant parts of our model. Jumping into Simulate, there are a few pre-processing steps that we have to do. We need to add a material. We need to add loads and constraints. So loads are going to be forces that this thing is exposed to. Constraints are going to control how this thing can move. So maybe a bracket is screwed into a wall. A constraint is going to model that motion restriction. So we have materials, we have loads, we have constraints or motion constraints. We also have meshing, so we can break our model down into little chunks. We can control how Creo does that. So that's those are what I would call the 4 kind of essential pre-processing steps, and we'll walk through those once we get into the software. We're then able to set up and run our analysis. So that's going to analyze, depending on the conditions I give it, so how this thing is going to be loaded and constrained. It's going to analyze what's going to happen. And finally, I can view my results. Results can be viewed in a fringe plot. So that's what we see on the screen here. The model is going to light up with different colors, showing us where the stresses on our model are highest. But we can also view our results in graph form. We can create our own custom measures to view specific results, like Y displacement at a certain point, really getting as specific as we would like. And then step 5, they put this as optional. I would say it's pretty required, but step 5 would be to make design changes. Use your results to make small changes to your design to optimize your design. This design optimization part of it is something that we're going to be getting into in the coming parts of this webinar series. Okay, so I'm going to be doing a demonstration now of this process. So I have a model here in Creo 10. This model is a solid bracket. We can see that this is a pretty basic part. We are going to be loading and constraining this. And I think that a part like this is good for your first simulation. Keep things pretty simple. So the way we get into Creo Simulate, so you can see that this is just my normal Creo 10 interface here. The way we get into Simulate is we're going to go to Applications and Simulate. Now, if you do not see this, or if it is grayed out, that does not necessarily mean you don't have the right license. There is a possibility that this option's grayed out and you can't click it, but you have the license that is needed. So if this is grayed out, feel free to reach out to me. I'll walk you through that process. Usually it's just a missing piece of software rather than a licensing thing. So I'll be able to get on a call with you and I'll be able to run the right setup to get this button working. So we're going to go Application Simulate. That's going to put us in Creo Simulate. We'll see that it's built right into Creo pretty seamlessly. I'll just cover very briefly the options we have in the top left up here. Structural versus thermal mode. This is going to determine if we're doing a structural or a thermal analysis. Additionally, in model setup, we have some advanced options. We can do 2D analyses rather than 3D. Okay, so now that I'm here in Simulate, there are going to be, as I said, 4 or maybe 5, if you count an optional step, let's say 5 pre-processing steps that we are going to have to do every single time we run a simulation. I always keep these things in my mind and go through this mental checklist to make sure I'm not missing a step. The first of those steps is going to be applying a material. It's worth noting that even if you applied a material at the parametric level, so when you are designing this part, if you applied a material at that point, even if you did that, you're still going to have to do it again in Simulate. So we're going to have to go to material assignment, and I'm just going to assign this to steel. Okay, now my material is assigned, that step is done. Next, I'm going to be adding my loads and constraints. As I mentioned, loads and constraints control how this thing is going to be set up to model this its real world loading scenario. So in this case, we are going to create a displacement constraint on these back two surfaces. What this is going to do is it is going to lock those surfaces in place so they cannot move. Another way to think of that is we're going to be applying a perfect super glue that's going to have infinite bonding power. We're applying that perfect glue to these two surfaces, and we're sticking this to a wall. These things, or these surfaces specifically, cannot move in any way. Next, we are going to be applying a load. We're going to be applying a load to this top surface region right here. So again, in this example, we're locking these back surfaces, and then we're going to be pushing down on this top surface. We're going to see how this part reacts. So loads are found near the constraints of here. I'm going to do a force moment load. All right, I'm going to call this load 1. And I'm going to do 1000 in the Y direction. Oops, 1000 in the Y direction. And 1000 in the Z direction. If I preview that, we'll see that this force is going to be applied at a 45-degree angle going down and to the left. Each direction is 1,000 newtons. That means the total magnitude is going to be something like 1,400 newtons in that down to the left direction. So, okay. All right, we have our material, we have our loads, and we have our constraints. Now we have 2 more steps. They're technically both optional. The first of those is generating our mesh. If we don't do this step, Creo is going to do it automatically, but we're not going to be able to really customize the mesh like we would if we did it ourselves. So I'm just going to go ahead and just generate the default mesh. And we'll see that Creo is breaking our model down into these little discrete chunks. These are called finite elements, and that's where the finite element of finite element analysis comes from. That's the type of simulation that we're working in. Most simulation tools, really almost all of them, are FEA tools, which means they break the model down into these little chunks. And rather than do the math across the whole model, they do the math for each discrete chunk. Usually it's a good idea to refine your model a bit. We can see that these chunks are pretty big. We have elements that are very long and skinny. And our model is really 1 or 2 elements thick here. It would be a good idea to refine this mesh to make our elements smaller. So a way we can do that very quickly, I'm going to go ahead and use the measure tool. And I'm just going to see how thick this is. All right, looks like these two walls are 30 millimeters apart. Okay. Now I'm going to refine this mesh by controlling the maximum element size. I'm going to say across this entire component, my maximum element size, I'm going to make it 15. Okay. Now I'm going to regenerate my mesh. And this time we'll notice that my mesh elements are much smaller. We'll see I generated a mesh that's about 3 elements thick now, rather than, just 1 element thick. And we don't have as many of those long, skinny elements that are, going across the whole length of the model. This mesh is going to get me much, much more accurate results, but we do have to keep in mind that anytime I increase the amount of elements, that means the simulation is going to take longer to run. So simulation really, at least in terms of optimizing the mesh, it's more of an art than a science. I like to use the kind of at least initial goal of getting 3 elements at 3 elements across for any part of our model. But how accurate your mesh gets, how fine your mesh gets, it's really going to depend more than anything on your computational power and how long it takes you to run these simulations. The art to it is going to be getting your results as accurate as you can without making your simulation take weeks of your time. Okay, so I generated my mesh, I added my material, and I did my loads and constraints. The final step is an optional step, idealizations. And I'm going to make it easy for us today. We are not going to be doing any idealizations in the introduction webinar. So for us, we really only have those 4 required pre-processing steps: the material, the load, the constraints, and the mesh. Okay, so now that I have all my pre-processing done, I can set up and run my analysis. So to do that, I'm going to jump into analyses and studies. If I go to file, we'll see that I can create a new analysis. We have new static, modal, buckling, fatigue, pre-stress, dynamic. This introduction to Simulate, we're doing static analysis. We'll talk about some of these other ones in the future. I'm gonna go ahead and name this brackets. We'll see that I can choose my constraints and loads. I want to include the 1 set of each that I made. I didn't do anything crazy with that. And then down here in convergence, we have some options for our convergence method. I'm not going to get deep into this, but I really do have to spend a few minutes and talk about what this is referring to. This convergence method is going to determine how many times this simulation is run. So if I put this on quick check, this simulation is just going to be run 1 time. We're going to get some set of results, and those results are not going to be accurate. I would never trust the results of a quick check. Quick check is only to be used if you just want to see if your simulation will complete it all. If you want to make sure that you set this up right and that it'll run, then sure, use a quick check. But if you want to get any kind of usable results, do not use a quick check. A single pass adaptive is going to run a total of 2 times. It is going to run once. It's going to get some preliminary results. And without getting into the math of it too much, it's going to use those preliminary results and it's going to run the simulation again using more accurate formulas. Using the first results to, improve those formulas in a proprietary PTC way. Single pass adaptive is going to be a really good balance of getting you pretty accurate results while not taking a whole lot of time. I recommend using single pass adaptive to get preliminary results and then, refining that with a multi-pass adaptive analysis later. This multi-pass adaptive analysis, I said quick check runs once, single pass adaptive runs twice. Multi-pass adaptive is going to run up to 9 times. So again, without getting into the math too much, this can range from a polynomial order of 1 to 9. If I set this between 1 and 9, this is going to run 9 times, or at least a maximum of 9 times. It might stop early. But again, it's going to run, it's going to get those results, and then it's going to run again with more accurate formulas. So each time you're running this, in theory, you're getting more accurate results. So multi-pass adaptive is what you want to use if you would like to get the most accurate results. Convergence, that is something that I will touch on very, very, very briefly. I'm not going to get into singularities. If you know what those are, then hold tight again for a future webinar. But essentially what this number is, so if I set this to 10, this means that as this runs through potentially 9 times, so let's say this runs through past 7 and gets a maximum stress of 10. It then runs through the next pass and gets a maximum stress of 10.5. So that result is within 10%. Since I set this percent convergence to 10, that would deem those results sufficient. So essentially, if I lower this percent convergence, it's going to make it more likely to run the full 9 times, or at least more times than I would otherwise. So lowering this, in theory, more accurate results, but more simulation run time. Okay. Now, before I run this, I'm going to do a few other things. I'm first going to go into run settings. This is where my output files are going to be deposited. And importantly, this memory allocation down here, this is going to control how much RAM my computer is able to use for this simulation. 128 MB is not very much. Most computers nowadays have gigabytes of RAM. I think mine has 16 or something along those lines. As a rule of thumb, you're generally safe to use half of the RAM that's available to your computer. So for example, if my computer has 4 gigs of RAM, then I should be safe to put 2000 in here, because 2000 MB is half of 4 GB or 4 gigabytes. So definitely be sure to change that. It's going to give your computer a lot more RAM to work with. Final steps before I run, I'm going to click this this check model, so info check model. It's going to tell me if there are any errors that it catches immediately. And most importantly, I'm going to do a file save. Those of you who have used Creo for a long time, I'm sure you know, save early, save often. Especially that is true with Simulate. I would say some percentage of the time when you hit run, you will get a crash. It's not a very high percentage of the time, but it happens. So definitely do a file save. I'm going to click yes, I want to run interactive diagnostics, and it is going to run. While this runs, I can go ahead and display study status. And we can see this thing as it runs. It's going to give us a whole lot of data. So you can see that it says elements not converged, about 9,000 on pass 2. So it's going to run another pass. We're now on pass 4. As I indicated, this is a multi-pass adaptive. All right, so I'm actually going to stop this and change my convergence settings so that it takes a little bit quicker. I think I just changed my convergence here to 5. I'm actually just going to do single pass adaptive with my mesh changes just for demonstration purposes. That wasn't going to take a ridiculous amount of time. That was looking like it was going to take 5 or so minutes, but just to keep things moving, I'm going to run this just a little bit faster. Yes, I want to override the previous results. Yes. Okay, so this time I just did a single pass adaptive. That means that this is only going to do 2 passes of the simulation. It's only going to run this thing 2 times rather than up to 9. Okay, and my run completed. Now I'm going to go ahead and open up my results. We'll notice the results are going to open in a separate window, the simulate results window here. And I'm going to first show a fringe plot in megapascals. This is going to show me the stress at any point along my model. The fringe plot means that it's going to show the results overlaid on the model itself. So we can see my maximum stress here is showing at 4.28. So I can look at the top of my legend here in the top right, but 4.28 megapascals is my maximum stress here. I can click model max as well. It'll put a little marker here showing the maximum stress value in the exact position that we're able to find that. Now, depending on our material, we can use that max stress value to decide if our model is going to fail. Every material is going to have some kind of maximum tensile stress failure condition. So these materials are going to have some stress value that they are going to deform beyond repair or beyond the point that they'll naturally spring back to. At that point, we consider that a failure. As I said, every material is going to have a specific stress value that is going to lead to that failure condition. So knowing my material steel, I know that we're very safe with this value. Now, additionally, I'm just going to display my displacement, and I can actually animate that deformation as well. There we go. I'll overlay undeformed. That looks good. So I can actually see how this thing is going to move when it is exposed to those loads. It's worth noting that this is not to scale. Looks like this is about 10,000 times exaggerated. I can make this to scale if I would like. So I want my scaling to be 1, okay. Now this is going to be the scale. We can see that this part is really not moving at all, at least anything that we can see. Our maximum displacement is 0.006, and that's in millimeters. So very, very small, but we can see how that looks. All right. We have the ability to create multiple views in here. So if I want to also go back here and just create a stress graph, I can show them both at the same time. All right. Besides that, I can view my results in terms of graphs as well. So if I have a specific point and I want to graph max y displacement, I can do that. I can even create my own measures if I would like. Right. Now you might have noticed I closed out of that a little bit too quickly. But you might have noticed that when I did close out of this window, it asked me if I wanted to save. I just like to point out that this analysis is going to save regardless. What we're saving here is just the configuration that I set up of this window. So we can safely hit don't save and we won't have to rerun our analysis again. Okay, so once we have those results, we're able to understand what our maximum stress is and where it falls. If this maximum stress is any sort of problem, then we would want to make design changes. We'd potentially want to make this fillet radius bigger because that in my mind would be the easiest way to make that specific area stronger. Now, additionally, we can look at all the areas that we have pretty much no stress whatsoever, or at least very low stress. All of these places in the dark blue, they're probably over-engineered. We're probably safe if we would like to remove material from those areas while maintaining a good safety index. So the next step, going forward on this example, would be to further refine the model, run our analysis again, run our analysis using multipass adaptive instead, further refine our mesh, et cetera, to get better results, make improvements to our model. Okay, so that brings me to the end of my demonstration. So a little bit about just game plan going forward. In future webinars, I am going to cover additional functionality of Creo Simulate. So that's the tool that we just looked at. Things we're going to cover are design optimization. So that is the process that that we can improve our model. So we can take these results and we can figure out what design improvements are going to be the most beneficial for us. I'm going to cover thermal analysis in a future video. So that's going to be heat transfer. I'm going to cover modal, I'm going to cover buckling, etc. And we're also going to dive into, at a later time, the other simulation tools. So Creo ANSYS and Creo Simulate Live, two other very exciting tools. Creo flow analysis, generative design, etc. To just do a little bit of a recap, if you are on subscription for Creo, you probably have access to everything I just showed. Please reach out to us if you're unsure if you have access or if you think you're licensed but can't get into this in Creo. I'm happy to help with licensing. Happy to help you all get up and running with this Creo Simulates. At PDSVISION, we have a really great team of simulation experts that work with this software, with the whole suite, Creo Simulate, Creo ANSYS, Creo Simulate Live. We work with this stuff every day. I've mentioned that we offer training. We also offer, in case you don't have this software at all, we do offer simulations, so we will run simulations for you, conduct our own analyses. And of course, we offer software, global PTC and ANSYS partner, so we're able to set you up with any of these tools that you think might be helpful. So I'm going to put my email address on the screen for technical questions. Just go ahead and put your questions in the Q&A if you can think of them now. But otherwise, my email is here on the screen, sebi.beaver@pdsvision.com. Putting the sales email up there as well, sales-na@pdsvision.com. And feel free to check out our YouTube page, PDSVISION on YouTube. That's where you're going to be able to find this webinar in the coming days. Okay, so I'm going to go ahead and open it up to questions really quick. I know we got at least one that came in. So I have a question, can we do a coupled thermomechanical analysis in this environment? Or do we need additional tools and license? Okay, so two kind of parts to that question. Number one, can we do combined thermal and structural analysis in Simulate? The answer is yes. So what I can do, I can run a thermal analysis. We can figure out how this thing is going to deform and bend and move when it's heated up. I can then use that heat load or those heat results in my structural analysis by applying a heat load based on the results of my thermal analysis. And yes, I can do that kind of combined analysis in Creo Simulates. Now, as to whether you can do that for free, or I should say with Creo Simulation Elite, which most people have for free, can we do that? The answer is no. So to do thermal analysis in this environment, you need a minimum of the middle option here. So the PTC Creo Simulation extension there, that will open up the whole thermal analysis, can of worms, and that'll include doing combined. Oh, actually, nope. Looks like I was wrong. Combined structural thermal is actually the far right tier. Sorry about that. So to do the thermal analysis, you need the middle tier, but to do combined structural and thermal, you would actually need the highest tier, the advanced simulation. My bad. I didn't realize that was a separate thing. Okay. Now I do want to mention you can apply a temperature load. This is actually just part of the base structural license pack. So I can say maybe this surface has a temperature load applied to it. This surface is 150 Celsius, whereas the rest is 70 Celsius. And that'll apply some amount of deformation to my model. So we can do a temperature load, but that's not quite the same thing as running a full thermal analysis and incorporating that in here. So yeah, if you wanted to do that, the full thermostructural analysis, that would be the highest license tier, but it is available in this software. So in Creo Simulation, just requires this license. All right, let's see. We got another question. What can we do with the weld function in the refine model tab? Okay, so jump back to simulate. We go to refine model. We'll notice we have this weld function here. So, long story short, this is used for two different things. Number one, we can bring in weld geometry. We can generate an idealized weld here, or we can use the Creo weld extension, which is built into Creo. It's something different. We can bring in those welds in here as well. Additionally, this weld tool is used for joining together shells, which we didn't cover here. But if you're aware of shell idealizations, welds are used to join together those as well. If you are interested specifically in doing welds and simulate, so that's what it's used for, to join idealizations and to create idealized welds. But I just add some more additional context. If you are interested in doing welds in Creo Simulate, actually, bear with me here really quick. I'm just gonna go to Google, Creo Simulate welds Army paper, maybe. So here it is. There's a very good Army paper out there. If you're gonna do welds and simulate, I would definitely recommend downloading and reading this. Here we go. Yep, really good stuff. So this covers the best practices of how to use the weld tool for accurate results in Simulate. I would definitely recommend checking this out if you are in reading through it. Conclusions here this is all really, really good stuff. So yeah, that's the short answer, and I would say for the long answer, read through this paper. It's really, really good. Okay, I think that is all I've got for now. But if you all think of anything else, people from YouTube that are seeing this in the future, if you all think of anything and you have questions, reach out to us. So either me or sales. As I said, we have an excellent team of simulation experts here at PDSVISION. Wherever you are in your simulation journey, just getting started to the most advanced, we are here to help. Reach out to us. And And that is all I've got for today. I want to thank you all again for attending this week's edition of Webinar Wednesday.